Welcome, ladies and gentlemen, and welcome back to another tutorial on landscapes materials. If you recall, last time we went over anti-tiling. I finagled with my numbers a little bit, and as you can see, it's even more difficult to see the tiling. And as well, I'm sure you noticed I changed up the coloring to make it look more natural. I'm certain that you yourself have played around with it. However, just to be sure, for me, here's my numbers, what I did for the anti-noise, everything that I changed. And then if you come down here to the UVs for each of them, these are the changes I made. With that said, for those that are genuinely curious, here's my new curve between 0 and 1. As you can see, this is everything I got here. That's pretty much how we have it. Now, if I come back here, yeah, it's at 2. If I go to 3, it starts looking ridiculous, obviously. 2.3 is a good strong number right there to help see the difference more efficiently. And it still, in my opinion, looks pretty nice. So that said, this week, or this episode I should say, we're going over triplanar projection. Now, triplanar projection is very complex. It's very difficult. Uh, there is a node called um, world. I can't remember what it's called because I haven't used it in so long. There is a, a world alignment node of some sort. I can't remember what it's exactly what it's called. Yeah, I can't remember what it's called, and that's fine. That does triplanar projection, and it does well enough. If you want a better explanation as to why I have the triplanar the way I'm going to have it, again, this is a Ben Cloward thing, because again, this is messing with UVs, and he is a UV master. Um, so if you want to learn the core of triplanar and understand how it works by definition and everything, I'll leave a link in the description going to the tutorial series that he has for triplanar projection that helps better explain these things. But here I'm just showing you how to get it set up. Now, because of the complexity of triplanar projection and how easy it is to mess up without using material functions, I will only be doing the triplanar projection today. I will not be adding it to our current code because, as you can see, this is already a mess. And you may be wondering, it can't really add that much. Well, here's triplanar. It's nearly as large, if not as big or larger, than not triplanar. And as you can see, I didn't even add the coloring or anything, which would be easy to add. I just add it right here. But I want to focus just on triplanar projection. So that you can better see how it works, if I come here, you see this versus, if I come over here, sorry, this. So why would you want that? Well, that's easy. If we come here, we come all the way over here, we have stretching. And it's saved, let it compile. There's no stretching. Stretching gone bye-bye. Now you can see the different patches between which mask it's using, whether it's using the XY or Z mask, but that's easy enough if we come here, because so much has been removed now. Triplanar blending I have set to 8. If it's at 0, this is what it looks like, a blurry mess. I've found that 8 is a good starting point, and then you can adjust it depending on the texture. I don't advise going over 100, and here's why. Let's see if it'll happen at just 105 with this one. It's not, so I'll just go straight to 200. Things are breaking. If we go to 150, whoa, whoa. There's still none happening with this material in this way. But as you can see, the lines are starting to get too sharp. So it's starting to get easier to see the difference between the masks. You also have the issue with that 100, 65, we go to 8, 20, 50. I usually stick between 50 and 100. It really just depends again on the texture and the size that you're doing the textures. So, without further ado, let's take a look at this monstrosity. That way you guys can get it set up. So, what I did here is I took each of these textures that are down here, right here, and I multiplied them by 3. That's the easy part. The next thing that you're going to want to do that lerps these all together is what lerps all of these together. Yeah, that's going to be fun. So the first thing you're going to want is a vertex normal world space. So it gets the normal of the world so that you can adjust the normal of the textures via the world, which is beneficial. You want absolute. For those that don't know, absolute value. You can always, like it says, hold Control Alt to learn more about it. And then a power, this is where the triplanar blending goes into. And then the dot product, multiply by 111, and divide the dot product by the power, and then split the components between R, G, and B. Now, I'll only show how it's working with this one, because they're all the same. So for the first lerp, you're going to want to put the G channel into alpha, and in the second lerp, you're going to want to put the B channel into alpha. They're going to come down here and put the top albedo and the top roughness, top normal, top everything you're doing. Put it into the top of this lerp. The second, the middle, put it into the B. For the bottom, put it into the B of the second lerp, and then connect it. Now, it's not going to look perfect because we're missing the UV math. It's still going to look all stretchy. So the next thing we want to do, let me delete that, is I'm sure you recognize these. It's right here. So the easiest thing to do is to select this, copy it, and paste it. And you're going to want to do it 3 times. Now that's not all you have to do. Obviously after you do it 3 times, I'll show you the way I did it, is because you don't want to mess up the connection, so I intentionally did it this way. I would then hold down Control and take it to where it's supposed to go this way. That way I know I'm taking exactly where it's supposed to come from. It's just easier that way, and it's not something you have to worry about. The next thing you need to do, this one, the very bottom one of your 3, does not need to change. There's R and G. which is what is right here, right here, and right here. This next one, it needs to be R and B. So the G changes to B. And in the third one, the G stays and the R, sorry, not the G stays. The R turns into G and the B, and the G becomes the B. That's a fumbling fun one. Once you have all three of these set up this way, is where the fun comes in. To make this easier so that you don't have to connect it all and then do this, make the multiply, and then add those and then put it back in, we're going to come right here. So what this does, if I understand correctly, is it helps turn this side and this side into opposites. So if we come right here, we see how this is going this direction. It's going to the right. We come over here, it's also going to the right, but if you think about it, that means the other side is now going to the left. So instead of just taking this, which without this, it would just take this one and it would look identical to this on the other side. So it would be going right now on this side when this one's going right, which means if we came over here, it would look like it's going left. So it makes everything uniform, which means that the normals and everything work as they're supposed to. So the first thing I want to get is the sign, and that gets the positive and the negative. So -1 and 1. Multiply it by -1, 1, 1. You're going to separate them into the masks of RGB. And then you're going to get an append node for each of them and multiply them by 1. Now, once all of this is done, you're going to want to get 1, 2, 3, 4, 5, 6, 7, 8, 9 multiply nodes. Well, more if you're using more texture samples, less if you're using less. Just, I need 9. If you're following me exactly, you'll need 9. So from here, I'll just take these 3 to show. The appends are going up here on A, and the offsets are going into the B. And you need to do that to all of them. And then once that's done, you take these to their respective locations. So that there's some separation. So for these guys, obviously I have the split component because RG and B for this is a mask for me, which goes to my ambient occlusion, roughness, and world position. Because like I said, I'm not doing any special things with this one. I'm just getting it. I'm showing you guys how it works. So that's why that is there. So anyways, once you have these all lerped together and put in there, these two are done. That's everything. With normals, you've got to do things differently. Otherwise, when they're projected onto the world, the normals aren't going to look correct. You're going to see places that look like they're higher, that they're supposed to look like they're higher, but they're actually looking like they're lower. Again, Ben Cloward goes over that in amazing detail in the final video of his Triplanar Projection series that explains it amazingly. The guy's a genius with UVs. That's all I got to say about it. So to get this, we have some fun to do. So that we don't forget, get these two lerps ready, and get a transform vector. And you need to change the source from world space and change the destination to tangent space. because these textures are in tangent space. So they need to be in tangent space. The next thing we want to do, once you have these connected up, just these get connected to the same alphas as the rest of them. But anyways, once you're done with that, vertex normal world space, split component, and then you're going to get signs, so -1 and 1, multiply it by -1, 1, and then split those. So that's essentially doing what is right up here. Only instead of doing this right here, it's just doing this, because that's all you need. So this next part is quite complex. We're going to separate this stuff immensely to make it a lot easier for you to see and understand. So first things first, if we do this actually, so that we just pull aside everything so that it's easier to see this. The first thing you're going to want to do is get an append mini node and an add, and a multiply, and obviously another multiply. Once you have these connected to each other, you put the R here, and from here, you get the B. The reason you're doing that is to, again, make sure that the normal looks correct on the R value, so that you don't have indents where they're supposed to be outdents, if that makes any sense. And then in this add, you go with R, so you're adding R and R together. And then with this one, G and G, you're adding G and G together. And with this one, B and B, you're multiplying B and B together. Now, unfortunately, that's the easy part. The other two are a bit more complex because we have to swizzle. We have to change the RGs and Bs so that they look correct despite being projections. So next we'll grab this one, bring it over here. Oh, sorry, forgot this. Bring this up here so it's easier to see. So now, instead of add, multiply, it's add, multiply, add. And you have this multiply and this multiply. Now this multiply, you're just multiplying by -1. So that's changing all of the green channels into the negative to make the projection correct. And that is down here added to this one. The next thing is this multiply, which is again the red, but this time multiplied with the green. Next, you put the red up here, but here, oh, yep, is also the red. And now when you get to this blue channel, blue that is on the bottom is instead in the middle. And if you come here, green is right here. So blue and green are multiplied. And then here in this add, it's green and blue added together. And that's that one. Now if I come over here, clean this up again, bring this back together, the next and last one is even, in my opinion, more jumbled up. It's the most swizzled out of them all. So I'm going to do this to make it easier to read. Now it's multiply, add, add. And you have another multiply and another multiply. It's the green again, multiplied by -1, but placed here in the bottom. Not but, just like that one. And now, oh, and then this multiply is obviously red and red. So now you put this red here in the middle on the top ad. You put this green on the top ad of the bottom ad, and this blue at the top multiply. Then you put this red in the bottom of the multiply. You put this green in the middle ad for the B, and this blue on the bottom ad in the B. Once you've got that taken care of, I'm going to straighten these back up. For my sanity, it looks dirty no matter what, but the best I can do, right? Then once you have that all completed, whoops, get this, put you right here, put these right here. Once you have all of this set up and hooked up, you should have, if you change this to a cube, this very result, assuming you have your parameters, your variables that are right here set up exactly like mine, which mine are 1.500. And this is the result you have, which turns into this. Now, as you can see, it's clear that these are lined in like that, and it looks terrible for the simple fact that we don't have anti-tiling happening. With anti-tiling, that's virtually unnoticeable, and then when you start putting static meshes on the clip sides, it's completely unnoticeable because there's just simply too much for the eye. So that's triplanar projection in a nutshell. It's super complicated. I showed you how to set it up in 22 minutes. Ben Cloward has like a total of an hour and a half worth of tutorial. Granted, it's split between Unity and Unreal, so he can show you how to do it in both. So I'd say 45-ish minutes total explaining how it all works and setting it up with Unreal Engine. So I know right now it's upsetting. You want to see how this looks with this in there, but I can tell you right now, with already having 369, tripling that to 27 would make this get very complex very fast. Now, with that said, we are going to connect them, but not yet. Next week, we're going to be cleaning up our graph. We're going to be making material functions, and once the material functions are created, we are then going to utilize all the material functions to combine this with this and these, so that we then have a marriage of anti-tiling with triplanar and with all of the cool little hacks and tricks combined. And then after that, we're officially done with the material side of things. Well, I shouldn't say material, the layer side of things. So next week is the last episode for specifically focusing on a material function that goes into here. And we will start showing the math side of things for creating this to make this look like an actual landscape. So we'll go over the future episodes after the function is first we will go over normal and slope masks because they are very similar. They just do the same thing in a different way. Then we will go over height masks, and then we will go over area masks. Once we have those set up, we will then put, and we will be making those directly in functions from this point on, so we don't have to do what we're going to be doing now. with this next episode. So those will be directly already in functions. Once we have all of that set up, we will then work on creating an auto material with that information so it can auto populate your landscape material for you for those that don't have access to things like World Creator and World Machine and Gaia that can create splat masks for you. I'll even go over methods that, although still more time consuming than splat masks, will make it to where you can use things like the foliage tool to paint, and it's still sticking to only the material that you want it to. Because with auto material, it doesn't go based off of the material itself, it goes off of the layer, which an auto material is a single layer. Um, that'll make more sense in the future for those that don't understand. But thank you guys for watching, and I hope I see you guys in the next episode so that we can clean all this up so it looks essentially like this, but with, all of its parameters on this side. And please don't forget to like and subscribe and leave any comments and questions below, and I'll answer those in a timely manner. Thanks. Bye.